everybody. Welcome to our 10.7 notes about complex numbers. So up until this point, if we had a square root of a negative, we just said, it's not real, and we didn't deal with it at all. And today, we finally deal with them, and simplify them, and work with them, and use them, and it's going to be exciting, okay? So the main things that you guys need to know are actually in the top box, okay? The new thing that you guys are going to have is an imaginary unit. It's a little I, and I is defined as the square root of -1. So that's what it is, I promise. If you square both sides, that means that I squared equals -1. Those two pieces of information alone are going to set you up for success in this section, okay? So basically that means that we can deal with square roots of negatives. It's just that we're going to have i's now, okay, for imaginary numbers. So in example 1, we're going to write each number as a product of a real number and I. So I've got the square root of -5 first. So that negative means that I've got a -1 times 25 inside of there, right? So I've got the square root of -1 times 25, if you want to think about it that way. The square root of -1 is I. So that means that we have an I, and we also have a square root of 25. And you know what? I can take the square root of 25, right? The square root of 25 is 5. So this would be I times 5, or if you want to rearrange it, it would be 5i. And that's how that simplifies. In B, we've got the negative square root of -81. So the negative on the outside means that we're going to have a negative number. The negative on the inside of the square root means we're going to have an I. So if you kind of want to think about that as, okay, we're going to have a negative number, we're going to have an I, and then we're going to have a square root of 81. And then we can take the square root of 81 because it's a perfect square. The square root of 81 is 9. So I've got -I times 9, or if you want to rearrange that a little, that's -9i. Typically we put the i's last. It's kind of like a variable, except not, except that we know what it is. Okay? In C, let's see, we've got the square root of -7. So the negative inside the square root means, guess what? We have an I. So this is just going to be I square root of 7, and this time the square root of 7 is not a perfect square, and I can't simplify it at all because it's a nice pretty prime number. So that's all you can do on that one. And last one I have is the square root of -44. So the negative means I can take an I out, right? So I can have an I and a square root of 44. And the square root of 44, it is not prime, so let's see if we can simplify it a little bit. Let's see, 44 would be 4 times 11. And 4 is 2 times 2. So we've got a pair of 2's that we can take out of the square root. So we'll take the 2's out. We'll still have the I. So we'll have a 2 and an I on the outside of our square root. And then on the inside of our square root, we still have the 11 left. And that's it. Okay? So that's how you simplify if it has a negative on the inside of the square root. Okay? Next up, what if you need to multiply things that have negatives on the inside of the square root? Now, the weird thing is that if I multiply these two together, if I multiply -6 times -5, I get +30, and be like, ooh, that makes positive, and it's great. But the thing is that we're not going to get an accurate answer doing it that way, because we kind of forgot about the i's, okay? So what we're actually going to do is we're going to take out an I from the first one. So the square root of -6 is I square root of 6. It doesn't simplify any at all. 6 is 3 times 2. And from the second one, we have the square root of -5, so it'll be I square root of 5. And then we're going to multiply. Remember, when you multiply radicals, you multiply the outside times the outside, and the inside times the inside. So outside times outside, I times I would be I squared. Just like if you had an x times x is x squared, I times I is I squared. Okay? Square root of, and then let's multiply the inside of our radicals. So 6 times 5 would be 30. And it's not going to simplify at all. If you break it down, its prime factors, that'd be 3 times 2 times 5, and there's no pairs at all. But we can simplify with that I squared. Do you remember when I boxed it up here? I squared equals -1. We can simplify that further, okay? So I squared is -1, so we're actually going to have negative square root of 30, not positive square root of 30. Okay? Would you guys like to try the next one? Great. I'm going to give you guys a minute to try the next one. So pause the video. And I'll show you guys the solution in 3, 2, 1. Alright. We would do I square root of 8 times I square root of 6, which should give you I square root of 48. You can break that down and simplify it pretty nicely. We'll have 2 pairs of 2's that can go on the outside. 2 times 2 is 4, so we'll have a 4i squared root of, and we just have a 3 left on the inside. Your answer would be 4i squared root of 3. How'd you do? Great. Alright, next up is, what if we need to divide and we have negatives under the square root? It's the same idea. We're going to actually simplify things first, and then go from there, okay? So simplifying the square root of -80, well, the negative means I'm going to have an I on the outside, and then I can look at 80. So let's see, 80 would be 4 times 20, whereas 2 times 2, 20, I could say that's 5 times 4, and 4 is another 2 times 2. So I've got 2 pairs of 2's that can go on the outside. 2 times 2 is 4, so we'll have a 4 and an I on the outside. And under the square root, the only thing left is the 5. And in case you're wondering, I don't keep the 20 because I broke it down into other things. I don't keep the 4 because I broke it down as well. Okay? Over. On the denominator, we have the square root of -5. So the only thing I can do here is take out an I because there's a negative under the square root. So that would be I square root of 5. Now that we've simplified our radicals, we can do our division, okay? And the great thing is a lot of stuff divides out. The square root of 5 divided by the square root of 5 is 1. And I divided by I is also 1. So then I've got 4 times 1 times 1, which would be 4. Fun? Alright, I'll let you guys try the next one, okay? So for example 3b, I'll let you guys try it, okay? So, yet again, pause the video. Alright, work it out, and I'll show you the solution in 3, 2, 1. At the end of everything, the numerator simplifies as 2i square root of 10. The denominator is the square root of 10. And when you do your division, you're just going to get 2i. How'd you guys do? Pretty good? Great. The next thing that we're going to deal with are called complex numbers. So complex numbers have a real part and an imaginary part. And so they're usually in this format of a plus bi. So a would be a real number, and bi would be your imaginary part. So you might have like 3 plus 5i, or 2 minus 4i, something like that. That's what the complex numbers look like, okay? So we're going to perform each operation with complex numbers and write them in standard form. Really, when you're looking at complex numbers, they're going to act a lot like variables. It's just that it's a variable that we know what it is. So just reminding you guys, I is equal to the square root of -1. And if you ever have an I squared equals -1. Okay, that's the only difference. Ready? So in the first one, we have -1 minus 8i plus 9 minus 3i. So we're just adding like terms, which is great. Okay? So adding our real numbers together, we have a -1 and a +9. So -1 plus 9 would be 8. And then we can also add our imaginary numbers, which are like terms. And -8i plus negative 3i would be negative 11i. And that's it. That's our answer. Okay. With subtraction, my advice for you guys, as usual, is to distribute the subtraction first so that you know really if you're adding or subtracting those like terms. So I have negative 9 plus 4i. And then we're subtracting a negative 9, so subtracting a negative 9 is the same as adding a positive 9. Then we're also subtracting a negative 8i, and subtracting a negative 8i is the same as adding 8i. Okay, now that we've done that part, we can see which ones are like terms and add like terms together. So let's see, I have a negative 9 plus a positive 9, which would be 0. They're going to cancel out. We also have a 4i plus 8i, those are like terms. And 4i plus 8i would be 12i. And that's your answer. Alright, next up is multiplication. So multiplication, I've got 6i times 4 plus 3i. You distribute just like normal, okay? So you're going to do 6i times 4, which would be 24i. Plus, you're also going to do 6i times 3i, so 6 times 3 would be 18. I times I is I squared. And this is where we need to remember that I squared is negative 1. So that I squared I have here, it's really negative 1. So we have 18 times negative 1, which would be a negative 18. So we end up with 24i minus 18, or if you want to put it in standard form, that would be negative 18 plus 24i. Either way is technically correct, it's just normal standard format is kind of an A plus BI format, in case you're curious, okay? But they're the same answer. Next one I have is 6 minus 4i times 2 plus 4i. So distributing again, we've got 6 times 2, which would be 12. We have 6 times 4i, which would be 24i. And then we've got negative 4i times 2, which is negative 8i. And negative 4i times positive 4i, which would be a negative 16i squared. Okay. From here, I already see some like terms in the middle here. I have 24i minus 8i, which would be 16i. So I've got 12 plus 16i. Then we have to remember, I squared is negative 1. So I've got negative 16 times negative 1, which would be a positive 16. So I actually have a plus 16 here. Then I've got like terms again, because I have a positive 12 and a positive 16. And 12 plus 16 is 28. So I'll have 28 plus 16i, and that's my final answer. Okay. I think we're going to go on to part, no, we have E. So in E we have one more, and again, you should be distributing. So actually, I'm going to let you guys try part E, okay? So if you haven't yet, go ahead and try part E, and yet again, pause your video, try it, and then I'm going to give you guys the solution. 3, 2, 1. At the end of everything, you should get 58 as your answer. Okay? So when you distribute, you're going to get 9 minus 21i plus 21i minus 49i squared. The middle terms cancel. Negative 49 times negative 1 would give you a positive 49. So you end up doing 9 plus 49, which will give you 58 as your answer. Hope that went well for you. I'll make another video for part 2.